morning, students. This is Elementary Statistics 1401, and today is June the 15th, and our next class is going to be on Tuesday, June 20th. On June 20th, I don't record anything. You're supposed to take your exam one, okay? And everything I'm going to summarize now is already available here. Exam one will be available for the entire day of June 20th. It'll be available like at midnight from June 20th, midnight till the end of the day. It'll be available for 24 hours, but you will only get 2 hours to take the exam. You can take it anytime on June 20th. Okay? And it'll be available for 2 hours. I won't be able to give you an extension on time. The exam, I believe, shouldn't take you more than 50 minutes or 1 hour, but you will get 2 hours. So keep your notes handy. Make sure you have a good calculator or you have access to a good calculator on your computer. Desmos is not a bad way to go. Uh, I will only cover section 5.1, 5.2, 5.3. If you do the MATLAB problems from these three sections, you'll be all set. Okay? Where would the exam be? To get to the exam, it'll feel like you're you're doing your homework. So it'll be in the same place, and it's all described here. Pearson MyLab Math Assignments area. What does that mean? Well, you click your link. Where's my assignments? My lab, it should say, well, let me fix it right now. My lab statistics assignment, not math assignment. Let me go fix it right now. Okay. Statistics. Assignments. Okay, so that's where it will be. Go here. Look for statistics, all assignments. It's going to be right here. Now, it doesn't show up because it's not June 20th yet. Actually, let me fix one more thing. Let me check one thing here before I forget. Yeah, I think your syllabus is up to 5.4. So I'm going to double check right now. Okay, guys, and fix it. So we have done edit 5.4. We're going to do 5.5 today. We're going to start. It'll be a part of our lecture, okay? I'm going to show you again how to get there. You just pretend you're doing your homework. You go there on June 20th. You'll see the exam is sitting there. Once again, you're going to get 2 hours to take the exam. You can take it anytime, but it has to be taken that day, June 20th. So let me go back and see the homework problems just to make sure I'm mentioning the right sections. I don't want to mess up because I know I'm being recorded. Yeah, so up to 5.4. All right, we will start 5.5. So let me say something in this regard. Um, Exam one is already here. I know you can't see it because it'll be available later. That's why you can't see it. There'll be about 20 questions. You get 2 hours. I don't think I don't see why you would need more than an hour, but you get 2 hours. One more thing. 5.5 is something we'll start today. 5.5 is a long, challenging chapter. Okay. I will do it. When I teach 5.5 face to face, it takes me about a week to do it. It's a hard chapter. It's a long chapter. In most books, 5.5 is split into three sections. In this book, it isn't. So just be aware, 5.5 will be started today, will be a part of our lecture today, but it will not be completed and it will not be included on exam one. Will it be included on exam two? Absolutely, you can bet on that. So up to 5.4 is what I expect you to know for exam one. It's all here, and some of you are doing your homework. I know that. This is all you're responsible for. Okay? All right. Another thing, some people asked me to do a problem from 5.4, and I'll show you since we are here. I'll show you what I mean. It's a hard problem. Actually, a couple of you asked me. I'll go show you the problem, and I will record it today. It will be recorded, but I'm explaining something. I think you'll understand. This is the problem, okay? It's a hard problem. Every time I click, no, not this one. My bad. It's from 5.3. My bad. Well, I'll get there. Don't worry. I think it's from 5.3. We'll find out. I think this is the one. So I just want to explain here. It's about tracks, movie tracks. So let me see what's going on here. It's a bit annoying, but I'll sort it out, okay? Well, I can show you the problem. You'll recognize it. But I wanted to make a point, okay? I just hate to waste your time. And the recording, just fast forward this, okay? I'm sorry. Okay, this is the one I'm looking for. So, guys, so let me explain this to you. I have like three people ask me to do this problem, which is fine, which is not a problem. I'll be happy to do it. But instead of doing the one with your number, I picked it up and I solved it. And just to let you know so that you understand what's going on here, every time I click, I get a different set of numbers, but it's the same problem about tracks. Excuse me, guys. So this problem. So I am going to work on the version I have. Okay. Every time I click, the number changes. I want you to see that. Okay. So instead of choosing a problem that the particular student wanted, I am going to choose my problem, but it's the same problem and it's going to take a little bit of time to do it. I'll do it very carefully. Okay. So be a little patient. This is like going back a little bit. So don't worry. We're reviewing in a sense, and then we'll start our new section, which is going to be 5.5, but we won't finish it. I hope that all makes sense. Okay, this is 5.4. Okay, suppose you just purchased a digital music player. Suppose you just purchased a digital music player and you have 12 tracks. After listening to them, you decide you like three of the songs. So let's jot down a few points. How many do you like? Three. How many do you, I'm just going to say dislike. There are 12 tracks. You must dislike nine. It's nice to know that. And the total is 12. Okay, just facts from the question. With the random feature on your player, each of the 12 songs is played once in random. Okay? So you're not going to repeat. So let's say it played your favorite song. Okay, that's not going to be played again. It's going to pick one of the ones that it hasn't played. That's what it means. Find the probability that among the first two songs played, you like both of them. Again, you like three songs, you dislike nine songs, you have a total of 12 songs. The probability that the very first song will be your favorite song is this. For A, it's going to be 3 over 12. Now, the next one, now the first song has been played. Okay? How many of your favorite songs are left? Only two are left. And so now you're going to play those two songs out of out of a list of 11 songs. Okay? So this is the answer. Now, you have to simplify it and get the answer in decimal or however your book wants it. I don't remember. They'll clearly tell you they're very specific about it. So I'm going to use my calculator to find the answer. Again, the probability that you will listen, you will get your one of your favorite songs is 3 out of 12. Now think of one good song is out of the list, and there are 11 songs, and two of them are your favorite. And the probability of now getting a favorite song is 211. It's called generalized multiplication rule. But I'm not just giving you the rule, I'm explaining you the problem as well. I'm going to find this. Two, 312s, 312 times 212s, 211s, I'm sorry, is this number. However they want to do it, okay? I'm going to write the whole thing. If they say correct to three decimal places, you're going to do it. If they say correct to four decimal places, you're going to do it. Your exam will be from the homework. It will, when you're taking the exam, it'll feel like you are doing homework problems. Done. Part A, finished. Part B, you like neither one. How do we do that? Well, let's find out. You like neither one. So the first song that you hear will be one of the nine songs. What's the probability that you're going to get one of the songs that you don't like? 9 over 12. Now, one of the songs that you do not like is gone. There are eight bad songs left. Okay, I'm just going to say it for the sake of simplicity, bad and good. Bad and good. Eight bad songs out of 11 remaining songs. And that's your answer. We're going to find out what that is on our calculator. I'm getting this 0.545. Done. C, you like exactly one of them. This one is a little tricky, okay? What you have to do, you have to make sure you understand this. You like exactly one of them. So we have two cases here, okay? The first case is you like the first one, you do not like the second one, all right? And the second case is you don't like the first one and you do like the second one. Got it? And then you have to add the two probabilities. Why are we adding? Because these are disjoint cases. First case, if they could have asked you, what's the probability that the first song is the one you like and the second song is the one you don't like? That would be one answer. And then they could have said that what is the probability that the first song you dislike and the second song you like? But now they're saying exactly one. That really means that. And these are disjoint events. Okay. And you have to add the probabilities. So I'm going to try to do it as carefully as possible without messing things up. Okay, what's the probability that you like the first song? The first song, you have three good songs out of 12. And then how many bad songs you still have? You still have nine. They played the first one out of 11 this time. I'm going to put it in parentheses. Okay, plus. Now, the second case is the first song is the one you dislike. First song is the one you dislike. That's going to be 9 over 12 times uh, the one you now like. There are three good songs left out of 11. Now, some of you will say, oh, I could have just found the first one and multiplied by 2. Yes, that would have worked. I'll do it this way. Doesn't matter. So, so it's a good idea, especially when you're taking your exam, to simplify some of these things. So when you enter things in your calculator, you're less likely to mess things up. So take a look. 3 times 9 is 27. And 11 times 12 is, let's find what 11 times 12 is. 132. Okay? 132. And I'm going to take 132. I'm going to do 27 divided by 132. And I am going to multiply that by 2 because the next one is exactly the same. I'm just using shortcuts, okay? You don't have to do it. You can just find the same thing again. That's the answer I'm getting, guys. It's a difficult problem, and you're going to get one or two that are difficult, right? Most of the problems I assign are fairly easy, I would like to believe, but this is one of the harder ones, okay? If they say three decimal places, 0.409. Now, very carefully, I am going to do the same thing all over again in part D with this new condition. If a song can be replayed before all 12 songs are played. So let's say, what does that mean? What does part D mean? That simply means that simply means that you heard your first favorite song, but there's a likelihood it can be played again. The computer or your MP3 player won't take into account. So repetition is allowed. Okay, so they can randomly pick the first one and then they can pick the first one again if they want to. Once again, I'm going to pause there for a brief moment. Part D, what is part D? I'm going to call it DA, DB, DC. Okay, I'm going to answer the same three questions in terms of D. So I'm going to get rid of all of this. Okay, DA. I'm going to call it DA. What's DA? So very carefully, guys. Okay, I don't know. It's raining hard here, so maybe it's a little noisy. We'll find out. So DA, you like both of them. What's the probability that you're gonna play the favorite song? There are 12 songs. You like three of them. 3 divided by 12. Okay. Now, the second one, the song that was just played can be played again because it's a legitimate candidate. So the second one, the probability that it'll play one of your favorite songs is also 3/12. Okay. You like both of them. Yeah, that's going to be 9/12. Not 9/12. 9 over 144. Okay. 3 times 3 is 9. 12 times 12 is 144. 9 over 144. So that's about this number. Okay. That's my DA. Let's try DB. So do you see why the denominator is still 12? Because it's always picking from one of the 12 songs, and the one you played was available. It can be played again. You like neither one. Okay, that's very similar. There are nine bad ones. The first one, the probability that you'll get one of those is 9/12. Now, these are independent events. When you pull one out, the computer doesn't know. The next one is randomly selected again out of 12. That's also 9/12s. And what is this equal to? We're going to find out in decimal. 9 square is 81 and 12 square is 144. I'm getting this. 0.5625. If they say round it to three decimal places, you're going to enter three. I'm just going to leave it like that. You get the point. Now, the last one is you like exactly one of them. So we have two cases, right? We have two cases. I'm going to call it DC. DC, we have two cases. First case, let's say it plays the one you like. The one you like. What's the probability that it'll play the one you like is 3 over 12. Now it's going to play one of the ones that you don't like. And that's the first one is the good one. The second one is the bad one. Now you're going to say the bad one first and then the good one. And let's find out. So on top, I get 27. The bottom is going to be 144. 3 times 9 is 27. And 12 times 12 is 144. However, you're going to multiply it by 2. You could add it all the same. Now, I know this is a hard problem, but I hope you can understand it. It's a good problem. Uh, so we are going to get out of this session real quick, and there will be a part two. I will start the next section in the next video. All right, guys? Stay tuned for part two.